This video is on the multiplication properties of exponents. A monomial is a number, a variable, or the product of a number and variables with whole number exponents. A monomial does not contain addition or subtraction, nor does it have any variables in the denominator or negative or rational, that is fractional, exponents. Here are some examples of monomials. 3x squared, negative 4a cubed b squared, and 5/6 t. The following are not monomials. 3m minus 4n, that's not a monomial because it has subtraction. 7 over a squared, that's because it has a variable in the denominator, it's not a monomial. X to the negative 6th, that's not a monomial because it has a negative exponent. And x raised to the power of 3/4, that's a rational exponent, that is not a monomial. An expression in the form of x raised to the power of n is called a power and represents the result of multiplying x by itself n number of times. X is called the base and n is called the exponent. So for example, here we have 3 raised to the 4th power. 3 is the base, it's the bigger number on the bottom. 4 is the exponent, that's what's the power it's being raised to, and what that means is 3 times itself 4 times. So 3 times 3 times 3 times 3, and if we were to evaluate 3 to the 4th power, we'd get the value 81. The property of the product of powers says that if you want to multiply two powers that have the same base, you need to add their exponents. So the rule is a raised to the power of m times a raised to the power of n is equal to a raised to the power of m plus n. Notice the bases are the same, the bases are a. If I'm multiplying those two power expressions, I add their exponents. So for example, x to the 3rd power times x to the 4th power is x raised to the power of 3 plus 4, or x to the 7th. Why does this work? Well, x to the 3rd is x times x times x. X to the 4th is x times x times x times x, which gives you 7 x's multiplied, which is x to the 7th. Let's take a look at this example here. So we need to simplify 2a to the a squared, b to the 3rd, c to the 5th, times negative 8 a b to the 4th power c to the 3rd power. So I'm going to think of this as 4 different problems. I'm going to deal with my coefficients, which are 2 and negative 8. I need to multiply those. Then I'm going to multiply my two powers that have a base of a. I'm going to multiply my powers with a base of b and multiply my powers with a base of c. So it's really going to be 2 times negative 8 and then a squared times a, b to the 3rd times b to the 4th, and c to the 5th times c to the 3rd, and actually probably multiplication for all of those. Okay, so 2 times negative 8 is negative 16. A squared times a, that's really a to the 1. So I'm going to add my exponents. That's going to give me a to the 3rd power. B to the 3rd times b to the 4th, that's going to be b to the 3 plus 4, or 3 to the 7th power, b to the 7th power. C to the 5th times c to the 3rd, I'm going to add my exponents 5 and 3, and that's going to give me c to the 8th power. So that's my final answer right there. Okay. Another property you should be familiar with is power of a power. That means to raise a power to a power. And to do that, we multiply their exponents. That's going to look like this. So if I have a raised to the power of m, and that whole thing raised to the power of n, that's going to be equal to a raised to the power of m times n. So for example, if I have x to the 5th power, and x to the 5th itself is cubed, that's going to be x to the 5 times 3, or x to the 15th power. Why does that work? X to the 5th to the 3rd power means x to the 5th times x to the 5th times x to the 5th, 3 of those. So if I were to use the property I did up above, the multiplication property, that would be x to the power of 5 plus 5 plus 5, which is x to the 15th. So let's try with this one. Here we have to simplify 2 to the 3rd, that raised to the 4th power, that whole thing raised to the 2nd power. So I'm not going to go ahead and, since I'm seeing this is going to get really big, I'm not going to evaluate 2 to the 3rd as 8. I'm going to leave this with a base of 2. So that's going to be 2 to the third raised to the fourth power is going to give me 2 to the 12th. So this inside the square brackets is 2 to the 12th, and when that's squared, that's going to give me 2 to the 24th power. So basically multiply your exponents. The power of a product, so in other words, I have two things being multiplied and I need to raise that to a power. So I'm going to find the power of each factor and then multiply. So the rule is a times b raised to the power of m is equal to a to the power of m times b to the power of m. So in other words, if this whole thing multiplied, this is your product right here, if that's raised to a power, it's each of those factors being raised to that power. So for example, if I have 2xy squared, the whole thing raised to the third power, that's 2 to the third power, x to the third power, y squared to the third power. 2 to the third power is 8, x to the third power is x to the third, y squared to the third power, multiply those exponents, and that's y to the sixth. Why is that true? Because this really means 2xy squared multiplied by itself 3 times. I can break it out as I did above, the coefficients, the x's, the y's, and I get the same thing. So let's give this one a try. Here we have negative 3 x squared y z to the third power, the whole thing squared, 2x y to the fourth z to the fifth, the whole thing to the third power. So let's deal with each part of that. Let me give myself a little more space here. Okay, so this is going to be negative 3 squared x squared squared y squared and z to the third squared. That's just the first part. So negative 3 squared is 9, x squared squared is x to the fourth, y squared is y squared, and z to the third squared is z to the sixth. Okay, that's just my first term here. Let's do this one here. So this is going to be 2 to the third power, x to the third power, notice I'm raising each of those terms to that power, y to the fourth to the third power, and then z to the fifth to the third power. That's going to give me 8, x to the third, y to the, multiply the exponents, 12th, and then z to the 15th. So now I have to multiply this by this. Now I no longer have a power raised to a power, it's just straight multiplication. So I can do 9 times 8, which is 72, x to the fourth times x to the third, add the exponents, that's x to the seventh, y squared times y to the 12th, add your exponents, 2 plus 12 is 14, z to the sixth times z to the 15th, 6 plus 15 is 21, so z to the 21 power. So here are a couple practice problems I'd like you to try on your own. Go ahead and stop the video and try these in your math notebook. Okay, let's take a look and see if you got these correct. So we need to multiply 4a to the third b c squared times negative 5a to the seventh b to the 12th c. So I'm going to multiply my coefficients, so 4 times negative 5 is negative 20. Multiply my powers of a to the third times a to the seventh is a to the 10th. b to the 1 times b to the 12th is b to the 13th. And c squared times c to the 1 is c to the third. Okay, let's try number 2. G to the fifth power squared. This is a power of a power, so I'm going to multiply my exponents. That gives me g to the 10th. And my last example here, I have negative 2x to the fourth cubed, 4xy to the fifth squared. So I'm going to raise to the third power everything in this first parentheses. So negative 2 to the third power is 8. X to the fourth to the third to the power of 3 is x to the 12th. 4 to the second power is 16. And x squared, y to the fifth squared is y to the 10th. And then multiplying those to 8 times 16 gives me 128. X to the 12th times x squared is x to the 14th, and then y to the 10th. So in this video we took a look at some multiplication properties of exponents, how to multiply two powers that have the same base, how to raise a power to a power, and how to deal with a product being raised to a power.